and those who are joining us on Zoom and in the room. I'd like to begin by situating ourselves on the unceded and traditional territories of the Musqueam people. And I actually say situating ourselves as opposed to acknowledging, based on some learning that I've been involved in this week around issues around that term of acknowledgement. And so we can chat about that at another time. These lands have always been a place of learning for the Musqueam people. And currently we often refer to these lands as the University of British Columbia, and the beaches nearby have their own colonial names that we provided them, but they've long been places and continue to be places that are very vitally important to the Musqueam peoples for recreating, for harvesting, for many, many different purposes. And also, I mean, these are their relations. They live in relation with these lands. As part of my privilege of being here at UBC in the capacity I'm in, I have the opportunity to connect with people like Chris and people like Dr. Sandra Scott and Lindsay Rogers, who's online, who share my passion for marine environments. And so one of the things I've started to do for my own learning and unlearning is to start investigating resources in our local education and UBC libraries, as well as resources available online, so that I can start to learn about the intertidal animals, marine life, plants from a Hunkaminam perspective and in the Hunkaminam language. And so I have brought a few resources here that I'm happy to share with you later that actually do use Dididat language, as well as Hulkamalem, as well as Hunkaminam. And there are some wonderful resources being developed. So I just thought I'd start with that and thank Chris Harley for joining us, and looking forward to having this conversation. Any of the resources I've gathered, I will also share with our online participants by link. Okay, so thank you. Thanks, Chris. Oh, and thank you to the Edith Lando Virtual Learning Center for their ongoing support of our work.
And thank you for the invitation. And thank you all for coming. I see we have future marine biologists in attendance, or maybe, I don't know, future professional skateboarders, I can't tell. So this is a great opportunity for me to sort of express my love for the intertidal systems that surround us on this campus and in this place and in the broader sort of Pacific coastline, because they're really wonderful ecologically. They're beautiful. They provide important things to us. And they are ripe for study. They're excellent living laboratories. I find them much easier to work in than forests, and you know, systems like that. So I'll start with maybe the bad news, which is global warming's already happened. Climate change has already happened. So a lot of what my students and I work on in terms of our research are the consequences and the implications of climate change, and we use rocky shores as our model system. So this is a pair of maps for the trend in minimum temperatures in the province, and then over there's the trend in maximum temperatures. And the color scheme goes from blue, where it's cooling, which does not exist on the map, through yellow, which is a little bit of warming, and oranges and reds are a lot of warming. The most depressing thing to me about this map is this is only 1950 up until 2001. So the students that I teach now were born in about 2001. They were born on a different planet than the one that I was born on. And they will never be able to visit the planet that I was born on, because we're on a trajectory that is not going to put us back to what 1971 was like for thousands of years. The other sort of depressing thing to start with is that amount of change doesn't include 9 of the 10 hottest years on record, which have all occurred in the past, 12-ish years or so. So climate change is going to continue. Depending on how terrible we are at managing our emissions and changing our behaviors, it may continue to accelerate. So we're locked into some change already. It could be quite bad. So I am very interested in understanding how ecosystems are going to respond to that, because we want to still be able to feed ourselves. We still want to have the places that, nurture us spiritually. There's a lot of things that we gain from natural ecosystems, and understanding how they're changing before those changes become irreversible both helps us prepare and then hopefully in some ways mitigate. Okay, so here is your brief primer on what climate change is doing in the ocean. So it's doing a lot of the same things that it does on land, with a couple of extra curveballs thrown in there. So we're emitting greenhouse gas emissions. The bus that I rode to campus on today, it's better than driving, but it's still putting in carbon dioxide into the atmosphere. That is heating the planet up. So it's heating the atmosphere. I hope you're ready for a nice hot weekend. It's also heating the oceans. And in fact, about 90% of the heat that's been added to the Earth system is in the ocean right now, because water can hold so much more. As a result of that, we're seeing sea level rise. That's in part because warmer water expands. It's in part because warmer air melts ice caps. So that's an issue in places like Delta, where they're worried about coastal flooding. The Stanley Park seawall gets destroyed every few winters now from sea level rise and storms. And we're also seeing changes in precipitation. So, as air temperature is warmer, it can hold more moisture, it changes wind patterns. And so in British Columbia, we're seeing a little bit more rain on an annual basis, but it's becoming more and more restricted to the winter, less in the summer, and we're seeing less of our precipitation as snow because it's warmer. And I'll get to the implications of that, because when that rain falls and then runs out through the Fraser River, or the snow melts, that changes coastal salinity. So the water that I can almost see from here out in this direction gets quite fresh in the summer and then is very salty in the winter. And then one thing that I won't have time to talk about today, but is also incredibly important, is ocean acidification. So when we add carbon dioxide to the atmosphere, that gets absorbed by the ocean. A very simple chemical reaction makes the water more acidic. And if you are something that builds a shell or a skeleton out of calcium carbonate, so that's mussels and oysters and snails and corals and a very long list of things, this makes your life more difficult. And even some higher organisms like fish have trouble with their physiology, lose their sense of smell. There's all kinds of strange things that happen when you change the pH of seawater. Okay, so all of that is going on in a complex system. So why should we care? I mean, it's been hot in the past, in the Earth's history. Why do we care now? Well, a lot of the things that we depend upon for food or for income are being impacted. So in this image, the big prickly thing here is a sea urchin. That's a multi-million-dollar fishery. This strange animal up here is an abalone. That is very culturally important to indigenous peoples. It used to be a commercial fishery until it was overfished, and now it's listed as endangered, so it's a species of conservation concern. Even this little pink paint, that's a seaweed that's vulnerable to both warming and ocean acidification. So, a lot of these species are things we care about for selfish reasons, because we eat them or we sell them to other people to eat. And then we have things like kelp forests and seagrass beds that provide habitat for a lot of other species. Those species are also at risk. Kelps, especially in the intertidal zone, are struggling right now, and we're seeing contractions in places like Barkley Sound around Bamfield. And then I can, just show general pictures of the beautiful biodiversity that you find on, rocky shores at low tide. And as an ecologist, I can cite papers at you that say that the more diverse a system is, the more resilient it is in the face of insults like a big heat wave or a drought or things like that. And that's true. But I can also stand here as a person and say that I love to poke around in tide pools because of all that diverse beauty, and it would be a shame to lose it. So I feel like we can fight for things, without having numbers behind it, but just sort of based on our passion for it. All right, you may have noticed that all of those photos were rocky shore photos, which is, partly because that's what I study, but it's also partly because this is a really terrific system to study these sorts of things. When you have hot weather, things die on the shore, and it's sad for the mussels, but it's useful for the ecologists because it helps us understand things. And I don't need, gene sequencers or, gel electrophoresis or all the fancy tools that my colleagues have. to say, oh, it got hot and then they died. I think there's a connection. So I like rocky shores at low tide because it's easy to see some of the effects of stress. The other thing that's wonderful is the interactions among species play out in a way that's really easy to understand. If you want to know what a starfish is eating, turn it upside down. The way they eat is they grab something and they press it up against their mouth. They pry the shells open, they turn their stomach inside out, shove that into the shell, and then digest it where it sits. But you can watch that happen. So this one is lunch, and that one was breakfast. And so, predator-prey interactions are easy to see. Competition. So if the sea star wasn't eating the mussels, they would overgrow all these barnacles. Facilitation, mussel beds and barnacle beds are both terrific habitat for all kinds of little worms and crabs and other things. So we've got all of these interactions playing out in a way that's way easier to figure out than, what is, the junco doing up in that tree. That's just harder to work on. And as a result of both this abiotic stress and these biological interactions, you get patterns, these nice repeatable patterns where this is a shore actually on the northwestern tip of Washington State. So there's a barnacle zone, and then a red algal turf, and then a mussel bed, and then a big pink crusty algae zone, and then kelps, and then a little bathtub ring of surf grass. And you can understand that system and think of it from the mussels' point of view. They live in this nice zone here. If you move them too high on the shore, that happens to them, and that's not good. If you move them too low on the shore, the sea star gets them, and that's not good for them either. Okay, so I'll give sort of 3 vignettes on some of the impacts of climate change on rocky coasts. I'll talk a little bit about the effects of long-term warming, talk a little bit about the effects of those changing patterns of precipitation. So the less snow, the skiers being sad also makes some other animals sad. And then extreme events like the big heat dome we had back in 2021, which was spectacular in the worst possible way for shoreline ecosystems in BC. Okay, so starting with some long-term trends, and I'll introduce you to a humble seaweed called Masiella. And I don't think the camera's following me anymore, so I'm going to try to verbally describe things. There's a scientist for scale. Just sort of behind his boots is that olive green turf. So that's the seaweed, and the upper edge of that, you see how it looks sort of white? That's bleaching. So that part of the seaweed bed's been out of the water for a little too long on a hot sunny day, and the chlorophyll just basically got blasted. And it's not necessarily dead, but it's definitely not happy. So that upper limit, you can sort of see that effect of, if it had been a little higher on the shore, it may not have survived that. A little lower on the shore, it was safe from that effect. And we can follow that through time. And my PhD supervisor, being the patient guy that he was, started working on that in the late 1970s. And this is just a graph showing you that, yes, it has been getting warmer in this area for the past half century plus. These are actually from Victoria, which will become relevant in a few slides. So summertime air temperatures are getting hotter. How might this algal turf respond as it gets warmer? Well, it doesn't like being out of the warmer when it's, or out of the water when it's hot, so it might have to live a little lower on the shore where the time it's out of the water is less. And in fact, that's exactly what we see. So first of all, credit to my supervisor, Bob, for being willing to collect these data for 15 full years where nothing of any interest at all happened. But then in year 16, which is about 1993, we had a very hot day. All it took was a single low tide, and you get this first blip down, but then it recovers. And then in 1994, there was another, and in 1995 was the hottest day on record at that point for Tatoosh Island. And the limit now has reset to a lower level. And then that happened again in about 2004. So those are the 4 single hot days that also had calm seas. That's the other important component here. And there were only 4 of them since 1987 when the records became reliable. And each time there was this effect at the upper limit of this species. That's not the only one that's changing. So that's where Tatoosh Island is, that last example. There was also a lot of zonation data, sort of where the upper and lower limits of things are, collected at all of these sites along the south coast of Vancouver Island in the 1950s by a UBC master's student in the botany department. And one of the best things that I did when I arrived at UBC is I went to the library and started reading old theses. And this one in particular, his name was Tom Widdowson, was just this treasure trove of information at all these different sites. And so I, made it my mission to revisit as many of these as I could to see the zonation patterns. And in the thesis, like nobody checks out thesis. So you pull it out and it's like a Harry Potter-ish, dust falls off of it and you open it up and it smells musty. And in the back, there's this appendix that describes the sites. It's like, you must go to the end of Rock Bottom Creek and then turn left and go 900 meters and you will see this rock formation and collect your data there. I quickly learned that the creek names have changed, so you need old maps and you start to feel like Indiana Jones. And then you get to the end of the creek and it's a 20-foot waterfall. It's like, why? You didn't mention that. And then you have to find a way down. And so, yeah, a lot of my time was, why didn't you pick the easy site? Anyway, as I was complaining about this to a friend, she said, "Oh, I know Tom. He's still alive. Would you like his email address?" And he was really helpful. He emailed me a list of Google Earth coordinates for all these sites so that I could be sure that I was right back to the spot where he was. So sticking with the animals, he got a lot of seaweed data too that I have a master's student right now repeating, which is a whole fascinating story. You can ask me about if you'd like. So we've got Balanus and Thamylus are barnacles. Middleus is the mussels. And so we've got the upper and lower edge of the mussel bed. We know it's gotten hotter. We know in that example with the seaweed turf, things have moved down. So the interesting thing here is when I went and redid these surveys, sure enough, the upper limits of the barnacles and mussels have come down because they don't want to be out of the water for as long. But that lower limit has not shifted. So it's not just that the whole shoreline ecosystem has moved down, it's getting squeezed. And we've lost about half of the extent of the mussel bed in 50 years. And thank goodness for Widdowson's data, we would not have noticed this happening gradually through time without having some of this prior information. Okay, so why does it not extend down the shore any further? It's because hungry starfish did not care that it got warmer between 1958 and now. And so they continued to climb up at high tide to about the same height to eat barnacles and mussels. And they've basically pinned that lower limit in place. And so as the upper limit's coming down, the lower limit's in the same spot. And of the 14 sites where Widdowson found mussel beds, they're now gone from 3 of those. So that collapse has been complete in 3 places along the south coast of Vancouver. If you were curious, these trends have continued, and in the 12 years since my data collection and my student Rebecca's, we've seen about the same order of change as in the preceding 50 years. So this is definitely an ongoing process. Okay, so my worry is that we have beautiful shores like this, really diverse, lovely mussel bed in the middle, and they're going to start looking more like this shore. So the one on the left is out on the outer coast of Washington. The one on the right is closer to Anacortes, if people know where that is. If you just drive south of the border by a little bit, it's inland hotter area. So you can make some of these comparisons in space as well as time. So we've lost the mussel bed on that island. We don't have the intertidal kelps anymore. A lot of the diversity is gone because that area is hot and because it's still covered in starfish. And so you can experimentally exclude the starfish and get mussels back on that. Okay. Oh, sorry, I had a computer crash that did weird things to the slides. So sorry, these are going to animate in each time. All right, so would you prefer I wait to the end for questions or accept them at any moment? All right. feel free to interrupt with questions if you have any. I'm happy to stop and go off in additional directions if people want. Okay, so reduced snowfall and higher swim. This is the system we have here is an estuary, a really big estuary, which means it's a mix of salt water and fresh water, and some of the circulation patterns are very stereotyped across estuaries. And our big input of fresh water is the Fraser River. And you can see it from space in the summertime because so much water is flowing out from snowmelts. You can see all the snow-capped mountains in this Google map image. As that all melts out in May, June, July, you get this big plume of fresh water into the southern Strait of Georgia. Depending on what the winds and currents are doing, that thing sort of laps up and down like a giant dog's tongue. And fills up this area with water that's maybe down to about 1/5 the strength of seawater. So that's quite a change if you're a marine animal like a starfish or a mussel or a barnacle, or a marine non-animal like a kelp. And just to show you how fresh it gets. So salinity is measured in parts per thousand, or PSU, which is so close as to be practically the same for my purposes, practical salinity units. But full strength seawater in our part of the world is between about 30 and 32. And the little dots there, that's Bamfield. If people have ever been out to the Marine Sciences Center there, that stays salty year round. It's on the edge of the wild open Pacific Ocean. And every once in a while there's a rainstorm and it gets a little bit low, but not terribly. The open circles are from the yacht club at Jericho. And the reason that I have those is my dog needed exercise, and it was close enough that I could walk her down there with a little, collection vial. And so I would get my little water sample, and then the next day bring it into the lab and measure the salinity. And you can see the effect of, when the snow starts to melt in April and May, that salinity drops way down from, high 20s down to about 6 at that site. So that's a big problem if you're a marine animal and you're used to it being salty. And different animals have different abilities to tolerate it. Of course.
So the water is running over the land and going into the ocean. So if there wasn't as much urbanization, would that
yeah.
make a difference at all, or?
Yeah. So the question, if that didn't come through on the mic, is because a lot of that runoff is coming off land and urbanization accelerates that runoff process, would that make a big difference here? For very local spots like False Creek, maybe. In the broader sort of English Bay scale, probably not, just because the Fraser is such a proverbial 900-pound gorilla that some of the local creeks are not going to shift the balance against what the Fraser is doing. Yeah, but in certain areas, that's going to matter. Okay, so this photo you've actually seen already. This is the hot site just down in Washington State. What I didn't mention when I showed the first version of this is it's hot and salty. And that one is Lighthouse Park over in West Vancouver, which is also hot, the same temperature, but seasonally fresh because of the Fraser. And huge difference in the ecosystem. Now, all that black is mussel bed. So, and this was like a bonkers year for mussels too. So I saw that, and at first I was worried because I had already generated my hypothesis about the temperature and the squeeze and why there's no mussel beds in, on Saddlebag Island in that previous photo. And then I came to Vancouver. I'm like, oh, am I wrong about temperature? And then I remembered that there's a giant river nearby and started looking at that. 2008 also, coincidentally, is when my first child was born. And so instead of going to Bamfield for my research, I had this epiphany that, oh, you know what? Starfish and mussels also live 8 blocks from my house. I can do some interesting science much closer to home, which keeps me in, within diaper change range. So exploring, the summer of Zoe's birth, the local area where you find mussel beds, they tend to be in the areas that are influenced by the Fraser River plume. So, here's UBC, Kitsilano, up into Howe Sound, out on the Sunshine Coast, and the straight side of Galiano Island and these other Gulf islands. But once you get on the other side of these islands where you're protected from the plume, even around the, around Point Roberts in towards White Rock, and I don't know why there's not mussel beds at that one. That was a little bit weird, but it is saltier on that side of Stanley Park than on the UBC side of Stanley Park. You don't see mussel beds in those areas that are consistently salty. So we can generate some hypotheses about why there are mussel beds in the Strait of Georgia. And from what you already know, Pyzaster is that purple starfish. Middleus is, in this case, it's the local blue mussel, also called the bay mussel, different species, but closely related to the one on the outer coast that I was talking about earlier. So we know that the starfish eat the mussels and they can limit their distribution. And the idea is that low salinity stress from Fraser River outflow in the summer, that might, mussels may not love that, but the effect is small relative to the effect of all that fresh water on the starfish, because mussels have shells that they can close. They actually have a more advanced physiology, so they can make some adjustments, and starfish are just like little permeable bags of water and really don't like fresh water. And I had an undergraduate who proved that by just putting them in beakers of different salinity. And let's see, this is the mussels. And so being down in very fresh water was confusing for mussels for about half a day, but then they sorted themselves out and they were all good for at least several days. And responsive just means that Tim poked them and they, you could tell that they were still, responsive. He also did this with Pyzaster, the starfish, and they just cannot handle the 5 parts per thousand that UBC Tower Beach in the summertime kind of salinity. And they just sat there like little curio specimens. They couldn't attach to the sides of the beaker. And about half strength seawater is about where they're just barely able to do things. And then full strength seawater, they were fine. Half strength seawater also turns out to be about where they quit feeding, which makes sense. If they can't hang on the side of a beaker fresher than that, they probably aren't going to be able to pry open a mussel either. And this is, that picture of the starfish turned over with the mussel. That was basically, me doing that hundreds of times at a whole bunch of different sites at different distances from the Fraser River mouth. And yes, if you are in like Kitsilano, where the water is fresh, the sea stars are not eating in June. They're just sitting there depressed. If you measure something in the Southern Gulf Islands or White Rock, or if you do it in Vancouver in the winter, then somewhere between a fifth and a quarter or a third of the population has got a meal at any given low tide, and you can enumerate that.
Are you saying that that's a little bit of like starfish sort of happy scale?
Yes, you could call that the starfish happy scale.
Yeah, indication of a happy start.
Yeah, so anything above about half strength seawater, happy starfish, unless something else is going wrong. We could talk about the wasting disease. There's plenty of unhappy starfish. But yes, definitely below 15, sad starfish. And we can plot a zonation diagram like we had considered for some of the other the temperature stuff. But now, instead of that upper limit being the part of the distribution that changes, and I'm going to just shade in the part that's kind of mussel bed. So all these little white triangles, that's the upper limit of the mussel bed, and the black triangles are the lower limit of the mussel bed, and then the purple stars are where the starfish are on the shore at low tide. And so places like Kitsilano and the west side of Stanley Park can have really extensive mussel beds. Lighthouse Park would be in here too. Once you get to the other side of Stanley Park, which is saltier, or onto the other side of Galiano Island, you're in these saltier areas, and the starfish are higher up on the shore. The lower limit of the mussel has been forced up by those predators.
Catherine on Zoom has a question.
Question, bring it on.
Is there any relationship between changes to salinity and sea star wasting disease that's left?
Ooh. Are there relationships between changing salinity and changes in the sea star wasting disease? Probably, but hard to say. Some of the early work we did with salinity and this species of sea star, we held them for 4 days. This was an undergraduate student named Miriam. Miriam held them for 4 days at about 15, and then at about 25 or something higher. And then, after 4 days, put everybody back into full strength seawater. And fortunately, she's kept them separated based on their original treatment, because what we didn't expect to happen was for them to look fine for 10 days and then start to die if they had been at half strength. And the way they died was they started to get lesions on their backs, their arms would fall off and crawl away, and then they would melt into little piles of goo. So the death of a starfish is really depressing to behold. That was done before sea star wasting was unknown, like this big epidemic happened several years after Miriam's experiments. And the progression of deterioration looks identical. So maybe in that case, salinity made the animals more vulnerable to a pathogen that's always around, and then they express those symptoms and they died. Or maybe starfish just die in that way, and you can cause it by salinity or by the pathogen. That's why I say it's hard to know. Turns out marine viruses are just excruciatingly difficult to study. And with each new study on sea star wasting disease, I feel like we know less than we did when we thought it was going to be easy back in 2013. All right. So with this sort of arrangement, and you may have noticed that textbooks or scientists tend to oversimplify things and say, well, the world is a mussel bed, and then there's a little gap, and then there's a big pile of starfish. But every once in a while, that's actually accurate, and there's a mussel bed, and then this little gap, and then a big pile of starfish. So that's over in West Vancouver in the wintertime when they're all actively feeding. And so the last piece of this puzzle was to put out some experimental cages, and this is another undergraduate named Karen who did this. And so the cage in the middle has 4 walls, and the starfish can't get in, and it's just mussels throughout. The open plot has a starfish in it, and there's no mussels there. And then this cage is missing 2 sides so the starfish can get under. That's just to control for things like, was it a floating log, or was it foraging sea ducks or something else? And so, no, it seems to be something that can crawl in under like starfish. So yes, starfish do set that lower limit. And so we have this pattern where that low salinity stress is impacting the pyzest or the starfish, which is impacting the mussels. And the question is, how is climate change influencing that sort of causal chain? And what we're seeing is less precipitation falling as snow in the winter, and therefore the freshet, when all the fresh water is coming out in the summer, that is becoming more muted. And there are some modeling studies that have looked at that. And so here's one that's getting a little bit older now, but more recent things have backed this up. So if you model the year 2000, you get a hydrological cycle that looks like the black line. So in the beginning of January, the Fraser River is not doing very much. A mere 1,000 cubic meters per second are flowing out. But then at the peak of the freshet, it's up to about 8,000 on average. Some years more, some years less. And as you move through time, the peak of the freshet is projected to get earlier in the spring because snow melt is happening sooner, but also lower because there's not as much snow to melt. There's more rain that's run off at other times of year. So that's the difference over here. But what the starfish care about is the height of that peak. And we've seen that through time already. So these are projections into the future. There are data that is collected at local, this is Environment and Climate Change Canada, but then local lighthouses collect salinity data. So with lots of year-to-year variation, the long-term trend is for the height of that peak to be smaller. And the corresponding salinity values for Entrance Island, which is you go past it on the ferry right as you're pulling into Nanaimo, things are getting saltier. So if it's getting saltier through time, is that good or bad for mussels? Well, we would predict that climate change is reducing the salinity stress by increasing the salinity, making it saltier. That should be good for the starfish, which should then be bad for the mussels. And this is one where there was not the salty Tom Whittleson to have all the data in the Strait of Georgia. but every once in a while you get hints of what things were like in other ways. So if you show up in front of people's cottages wearing bright yellow rain gear and carrying a rotating laser, they get very interested in what you're doing and will come down and talk to you. And this is on the Sunshine Coast near Roberts Creek, and we were surveying in zonation limits, and one of the property owners came down and we got to chatting about the project. And I asked him, well, how long have you been coming to your cottage? And he said, oh, geez, since I was a kid in the 1950s. Oh, you noticed any changes in that time? He's like, wow, there used to be more of this and less of this, and there used to be more mussels. I was like, ooh, that's my hypothesis, that there would be more mussels. And he was kind enough to share this photograph of he and his sister, and he didn't tell me the name of the cousin off the side of the rock there. So this rock, it's hard to see, but this is all mussels, top to bottom, except for patches where the kids had cleared them off for bait. And then after talking to my students and I, he and his sister climbed back up there, 50 years later, retook the photograph. So they're older, they're smarter because they now use a ladder instead of a rope, and the mussels are gone, except in just a little bit of the shadow of the north side of this rock. There's a tiny little bit, but that it's only one place and it's only a few time points, but it's consistent with this idea that lower limit is what's being pushed up. So that's sort of that balance of upper and lower, direct effects of some stress at the top, and then what's happening with predators or competitors at the bottom, and seeing how those change through time can really inform how the whole system is going to change. All right, how we doing? Okay, so now I want to talk a little bit about extreme events, because in addition to gradual changes, we're also seeing an increased frequency of things like heat waves. And when we get heat waves, they can be more severe. And of course, the 2021 event was just like so unexpected that people didn't think that was possible in 2021. And if you can track down somewhere I saw posted the text messages between all the meteorologists in British Columbia, and they were just losing their minds with the forecast because they just couldn't believe what the models were suggesting. But each day that went on, it's like, actually, now the model says it's going to be a little hotter.
This way people refer to it as the blob?
No, that's a good question. I do have chocolate. Let's see, how good is my mapping skills? Stuff happens, Vancouver Island. So the North Pacific writ large, the blob was a warm water event for 2 to 3 years that was mostly a little bit further out in the ocean. It did swash in, so I've got a field site on an island about there, and the water was maybe 4 or 5 degrees warmer than usual. And like you would notice it when you reached in to like rinse your hands off, you'd be like, yeah. Oh, it's because it's weirdly warm. So that definitely matters. The heat dome, I'll show a slide in a minute, mostly affected sort of, well, it goes a little further down, but the outer coast didn't get excruciatingly hot. It was the Strait of Georgia, Puget Sound, and then in Port Lytton, for example. All right, so one of my favorite quotes about sort of understanding climate change is that climate trains the boxer, but weather throws the punches. So climate doesn't kill a mussel, but a really hot weather day will. So trying to understand those punches and how they land is something that my students and I are working very hard on. And they've come up with some creative ways to do that. So here's Cassandra, who has modified a propane-powered turkey fryer into a heat wave simulator for tide pools. And she's cackling because the name for this is the Seaside Array for Understanding Thermal Effects, or SAUTÉ. And yes, we have published that acronym proudly. Another student named Sandra, who's just finishing her PhD now, hung propane camp heaters upside down over plots of this seaweed on the shore. This is just right down at the end of Dunbar Street in Kitsilano, and heated things up that way. And this one was particularly ironic because she was shooting for a temperature on these that would stress them, but not necessarily kill them, and was going to do it once in some plots and then twice in other plots. And the day she had planned for the second exposure was the hottest day of the heat wave, where the actual temperatures were 5, maybe 10 degrees higher on the rocks than her intended, danger, danger. So we had, this sort of thing. And if you can't see the scale bar on the right, it goes up into the 20s. And yes, this is in Celsius, not in Fahrenheit. So it got just ludicrously hot during the heat dome. And poor Lytton, usually when a national temperature record is broken, it's by fractions of a degree because we have, a century plus of data points. Lytton broke it on 3 consecutive days. The eventual, new record was 4.6 degrees hotter than it had been. And then the day after that, the town burned down and 2 people died. It's the kind of thing where if you would put it into a movie, the audience would be like, nah, it's a little bit too over the top. So just a really incredibly significant event for people and also for ecosystems. And I happened to be out with a student named Carter, who you can, the sharp-eyed among you will see him standing there on the 28th, on that really hot day. And this photo does not capture what it was like. We were worried about our safety. It was so hot. We would go out and survey a bit and then retreat into the shade and eat frozen grapes and drink water. This photo does not capture the smell of all of the animals that had already died, or the crunch of the empty shells as you walk across. So I have an informal quiz for you, and I didn't get my act together to send an official Slido poll. So you just have in your head what you think is the correct answer. Is now not air temperature, like the actual temperature of the animals on the shore. How hot do you think it got? 44.1, 49.6, 54.0, or 56.7? All right, so lock in your answers. I chose these numbers because the first one is what's known to be lethal to our local species of barnacles. That 49.6 is the new Canadian record high. 54.0 is the second hottest day recorded on Earth. There was a tie between Death Valley and Kuwait. And 56.7 is the hottest day on record. All right, here's what the shore looks like if you look at it through a thermal imaging camera. And the number up on the top left is just where the crosshairs are. The one to pay attention to is the one on the top right, which is the hottest part of the image. So some of the rocks were 52.4, and some of the mussels were 56.7, which was the hottest day on Earth, translated into an animal that can at best survive up into the high 30s. So this was just incredibly extreme. And if you're sort of paying really close attention to this low resolution thermal image, you can tell that these shells are actually open because the animals have already died. And a lot of things died. We lost starfish, we lost crabs, we lost clams, we lost snails. But of these things, those were all mobile species, and mobile species are not dummies. And so if they get a little bit of hot weather, they tend to hide because they know the next day might be worse. And so you find a lot of starfish, under the edges of boulders. And so, yes, some of those mobile animals died, but it wasn't a catastrophe for most of them. But if you are glued to the rock, like a seaweed or a mussel or a barnacle, this was exceptionally bad news. So that's what the local rockweed looks like when it's bleached and dying. These mussels are open and you can still see the meat inside. It looks like you've been served to them in a restaurant. The barnacles there are empty because they've lost the animal inside. Now it's just a little hollow shell that remains. So once this happened, my students and I were madly, traveling around BC to figure out where it had been bad, where things hadn't been as bad, and what the consequences might be. I'll just quickly show you. It got really hot. Down here towards the border near White Rock, the air temperatures were really, really high. Water temperatures in the Strait of Georgia are normally pretty high in the summer, but they were especially high during the heat dome. And the low tides in the Strait of Georgia are right in the middle of the day, early afternoon, the hottest time of day in the summertime compared to the outer coast. So Strait of Georgia, really, really unfriendly, overly hot conditions. The Strait of Juan de Fuca, you can see the blue here, how much cooler that is. That stayed foggier and things were okay. So just looking across a whole bunch of different species. So a few species of barnacles, there's oysters, mussels, a bunch of stuff on here. You don't need to know which is which. The general pattern, though, is out on the sort of outer coast of Vancouver Island, there's a little bit of mortality, but not awful. But once you get past Victoria and up into the strait, around Vancouver, up the Sunshine Coast towards Comox, mortalities were in excess of 50% at a lot of these places. And there were some really interesting local patterns too. And these are the kinds of things that are really good for showing students on the shore. So let's see, in this room, we've got a variety of different surfaces. So imagine that this is now in the intertidal zone. So a mussel could be growing on the top of a rock, or it could be growing on the north side, or it could be growing on a shallow, east-facing surface, all these different angles. So you can figure out sort of what the angle of incoming sunlight was at the hottest part of the day. So that's what the axis of this graph is. And then percent dead is just the mussels that died. And this is from the site in Stanley Park where we're going tomorrow for those of us who can join. So sunlight that was coming in like directly in is this 90-degree angle. Once you get down to 0, that's the edge of shade. So angles that are negative just means you're around a corner, under a rock, something like that. And the mussels that were in the sun mostly died. These are the sort of the big ones in the surface layer of the mussel bed. And so you could just easily go and measure that. And there's apps you can have on your phone where you just put it down and tells you the compass direction, the angle. There's this fairly easy equation to get that solar angle. And then you can plot things like this. So interesting local scale patterns that you can see in addition to those larger scale. Strait of Georgia was worse than the Strait of Juan de Fuca. And then the other interesting thing to me was the species that did the worst were our natives. They evolved in cold water. The species that did pretty well were the ones that were introduced. Most of our introduced marine species come from Asia because that's the shipping routes. And they, Hong Kong, southern Japan, those are warm water systems. These eelgrasses, anemones, oysters, sponges, clams, have evolved in systems that get warmer. And in fact, the Pacific oyster in this animal is pretty stoked right now that it's finally warm enough that it can reproduce. So we're seeing way more Pacific oysters just in the past 5 years because it's now warm enough for them to do really well in British Columbia, whereas previously they were a little bit harder to find.
Chris, can I ask you about the Olympia oyster, the little native oyster?
Yeah.
What did that do?
That actually did surprisingly well at the single place where I saw it. It's the native oyster was overexploited, partly during the gold rush. It was very popular, and there's a lot of restoration efforts for it now. So you can still find it if you turn over rocks or know just where to look. So there were places where it died as well, but I don't have enough information on it to give you a really confident answer of whether it did. Like, it did better than the mussels for sure, but how it did compared to the introduced oyster, that's a really interesting question. I don't think we know yet.
There's a good population at Point Roberts right now of the native oyster. Yeah, and it's been in the last, I would say 5 years, there's been a population explosion.
Okay.
And I wonder if it's the Lummi Nation. They're actually cultivating them.
Oh,
They
interesting.
have a clam garden of the Olympia or native oyster. And so I'm wondering if that really repopulated the beaches in the area.
Yeah, one of my former students is doing some surveys for Olympia oysters down in the sort of White Rock Crescent Beach area. And I'm going to go out and do some zonation surveys as part of a range-wide project from British Columbia to California this summer. So maybe I'll have to add that to my site visit list.
Yeah.
All right. Okay, so we've talked about long-term warming. We've talked about changes in salinity, one catastrophic extreme event. I used to sort of end talks here, and then I had a student ask how you can be enthusiastic about your job when all the news is so depressing. And so I had to talk about, the excitement of discovery versus the implications of those discoveries. And then another student raised his hand and said, so you're telling us you're pretty much dead inside. So ever since then, I try to end on a deliberately positive note so that people hopefully know that I hope I'm not dead inside. So what can we do? And we are not helpless in all of this. But it's an imposing problem, right? It's a global scale warming. It's taken governments a long time to even really agree that they need to do something, much less actually start doing very much. But there are local actions that one can take. And my favorite suggestion in the wake of the heat dome was someone in California emailed me and said, hey, I run a fabric company, and if you think it would help, I would give you for free 5,000 lineal yards of cloth that you could make into like pop-up shades. And then for the next heat wave, you and your army of volunteers can rush out to the shore and you pop, 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 and protect areas of the shore. 5,000 lineal yards is a lot of fabric, but the coastline of the Strait of Georgia is something like 2,500 kilometers. So in a practical sense, you wouldn't be able to protect very much, but it still wasn't a bad idea because it would work. And Amelia here has proved it because she just happened to have done an experiment where she put up shade cloth over some patches of barnacles. So if you want to protect a particular area badly enough, you could do that. But that's not actually the solution I'm suggesting, because Amelia was interested in these thatched barnacles and the habitat they provide for other things. And so the shades were there to sort of say, well, let's take barnacles away for some plots, but then in a few of those plots, we'll add shade back in to see what matters more. So this is just species rich as the number of species in these little areas, experimental replicates over in Victoria. And the red data here, that's the unshaded area with no barnacles. So there's not very many species that can tolerate that. That was really hot during the heat dome. If you add a shade, then you actually can have a lot more species. And that makes sense. It keeps things cooler. But it turns out you don't actually need a shade if you have barnacles, because barnacles give you the same benefit as this artificial procedure of your army of volunteers and 5,000 lineal yards of cloth. So if we can maintain our ecosystems with these important species that are providing habitat, we're going to be much better off in the face of these insults. And yes, this might wipe out a whole bunch of intertidal seaweed, and that's now you're in the very dangerous area of a subsequent event having really bad implications. But if you can recover quickly enough and keep these animals around, then all that diversity in the petri dish on the right can be maintained. And just let's see, yeah. So that's a local conservation effort that we can manage, and citizen activism can say, you know what, we need some marine protected areas where we reduce the impacts of these things to protect our local kelps or protect our local mussel beds or whatever it might be. And then here's just sort of an example of this happening. It's a photograph from up in Porto Cove in Howe Sound. And you can see all the dead mussels in the upper right, but when there was seaweed around, all the mussels underneath, they were just fine. So if we can keep some of those important species in play, keep the diversity of the system higher, we're more likely to make it through some of these extreme events a little bit better. So just a few concluding thoughts. One is that ecological changes are ongoing. In the media, we usually hear it framed, and this is the problem for our children to deal with, that we're leaving them. And well, that is true. But there was also the problem for our grandparents' children to deal with, because changes have been happening since 1950. If you want to understand how things are changing, this isn't just on rocky shores, this is anywhere. You need to understand all these changes in relationships among species. As it gets warmer, sea star wasting disease gets worse. As it gets warmer, coral reefs bleach, and then you don't have habitat for all the reef fish. So understanding those interactions really matters. We are getting there in terms of understanding how natural ecosystems work, but hint, hint for the younger generation, there's plenty left to learn. So we're learning new things every day. But I do think that some local efforts can really be helpful. So I will leave it there and open the question or a field for the floor for questions, and remind people that if you want to see some of these plants and animals in person, tomorrow at 6 o'clock at the Girl in a Wetsuit statue in Stanley Park, we can go and you know, pass some starfish around and look at mussels and see if we can find some other cool things under the rocks. Yeah, question.
So I can't remember how many years wasting disease was really prevalent. I know that there were some unique places up the coast, for example, that it was like even some stars and stuff like that were able to get by.
Yeah.
So was there a huge sort of proliferation of mussels during that time, going deeper and things like that? Is there any evidence of that?
Yeah, in some areas, yes. In sort of Burrard Inlet, it was strange because the sea star impacts were really patchy in time. So there are 5 places that I monitor regularly in the wintertime. And one of those went from, and it's an area, you know, about 50 meters in length that I pick at each of these spots. And one area went from 1,000 starfish to 1. So like that one was bad. And then the other ones looked okay. But then the next year it's like, oh, well, shoot, now it's caught up to a few of these other places. But because we have these big year-to-year changes in salinity, the natural lower limit is moving around a lot here. So I can't confidently point to a signal given all that patchiness, but on the outer coast, people were noticing that more in places like Oregon. The thing that we did see here is we have 2 common intertidal sea stars, the purple ones, Pisaster, and then the mottled star, which is like a sleeker gray one, that was less vulnerable to the disease. And that one, which had previously been quite rare, just was everywhere. So I think there was this release from competition when the purple ones really had trouble. And then the little gray ones are like, woohoo, we have so much to eat now. Yeah. So interesting questions, functional redundancy, and you know, all kinds of fun things. So,
Many years ago, I did research in Japan. We were shocked by that local business. We're looking at planktonic organisms and trying to think about how we could naturally concentrate them as a potential feed fish in for feeding fish, right? And one day we went out to look at these collection and vessels that we had, and all of them were dead. Everything was dead because there's this huge freshwater lens that sits on top, and we were denying the plankton the ability to get below.
yeah.
So places like that would have some very unique features just because it's a narrow fjord. I would think that Sound probably has something that has features.
Yeah, so if people couldn't hear that over Zoom, some interesting changes in Indian Arm, and the fact that there's a freshwater layer that sits on top has big implications. I've gone snorkeling there, and it was the weirdest thing because it was about 3 meters of clear water, and then this cloud deck of jellyfish that were right at that transition from salty to fresh. Lots of ecological change in Indian Arm too. Like the subtidal kelps are way less abundant than they used to be. We tried to go and resurvey their depth distribution, and there weren't even enough to measure at most sites that had been surveyed in the 60s. Yeah.
I guess more generally speaking, with the type of research that you do, are you able to integrate citizen science into it?
Yes, and after the heat dome, that was a big one where we had we published a little protocol. So, all right, Commander Compass is the app you want. Here's how you place your phone. Here's the numbers you need to write down. Here's the spreadsheet you can enter it into, and that was really helpful because it was mostly me and my students, if they happened to be in the field, would gather data from their sites. But there's big gaps. Like I would have loved to have gotten more information from a broader swath of spots. We were a little late getting that going. So we did get some input, which was really appreciated, but there's definitely opportunities for doing more of that. There are also just some general longer term monitoring things like starfish are easy to count and important. That snail that I showed you, that's a dogwell canucella that you can find really abundantly down at like 1001 Steps Park or the Crescent Beach White Rock area. And those are interesting because when the salinity gets low, like there's populations of them in kits, you lose a year class because it's the babies that are vulnerable. So you can measure them and say, oh, yeah, there's the 2+ year olds. no 1-year-olds that wonder why not, and then look and say, oh, well, the Fraser River was flowing really high last year, so that makes sense. No questions from the back?
I have a political question. Roberts Bank development, what's gonna happen to salinity when they expand that port?
Yeah, what's going to happen when they expand the port down at Roberts Bank? Probably not too much with salinity because it's not changing the Fraser directly, although the exact circulation there may change. A potential impact, well, other than the place that used to be Benthos and is now port, is it could change the way that sediment inputs are coming into the eelgrass beds in that area. So if you're now suddenly in the shadow of a structure, the sediment input rate might be lower. And if you're relying on that to keep up with sea level rise and that gets cut off, then you could drown a system. That's wild speculation on my part. I don't actually know how what the exact changes are going to be, but I hope they're thinking about it.
I hope they are.
Yeah. Yeah.
I'm wondering, one of the things that I'm following just recently is that when these changes happen so rapidly, like we get the heat dome for X many days, that's like rapid change. I mean, yes, mobile creatures can maybe find a spot, whatever. And I do more work around freshwater aquatic systems. And one of the reports that we're getting is because the switch this year from relatively warm temperatures to cold temperatures cause lakes to flip much quicker. And there's been considerable die-off of fishes, freshwater fishes, with that happening. Do you see similar kinds of things in, these kinds of events and those kinds of things in sort of coastal tidal systems as well?
Yeah, in terms of the timescales of change, definitely. In terms of like that overturning that you get in lakes and ponds, not necessarily. But there's shifts in when the plankton bloom, which may be driven by light versus when certain species release their larvae to go eat those plankton, which might be driven by temperature. And temperature is no longer an accurate cue for the light environment. And so the timing of those things is off. And I think in a lot of those cases, there's enough sort of adaptation and evolution that happens that things sort of keep up as long as the change isn't too rapid. But those really rapid changes we do have to worry about because, evolution is not going to save you if the change happens within a few years as opposed to a few millennia. Yeah, so the analogy I like is there's two ways to ride the bus. You can either wait for it to come to the stop, climb on, and then it gradually accelerates you up to 50 kilometers an hour, or you can stand in the street and just try to jump onto a moving bus as it hits you. You'll be moving at 50 kilometers an hour that way too. Yeah.
Question for Catherine. Would you be able to recommend any good sites for taking students to observe intertidal zones? I'm assuming in the Lower Mainland. Also, are there certain apps such as Seek or others that work well for K-12 level field study?
Good questions. I have not. Okay, so question one, are there good local field sites? Question two, what apps would be useful for engaging K-12 students in field trips? So local sites, yes, although I will plug Bamfield. They have an excellent public education program. So if you can get your school to send you out there, that's phenomenal. But locally, the place that we'll go tomorrow with the girl in a wetsuit is my very favorite local spot because, all right, let's draw this. Oh, so many colors to choose from. All right, so Point Grey is here. The Fraser River is coming out this way. You've got Falls Creek and some downtown stuff. Stanley Park looks like a duck head, and then Lighthouse Park and North Shore. This whole area is going to drop to about 5 to 10 parts per thousand in the summer because of all the fresh water, but it doesn't squeeze underneath the Lionsgate Bridge very well. So this side is more like 20. And as a result, there are way more species at the girl in a wetsuit than at, say, the tea house or Third Beach over on this side. So if you're going to Stanley Park, go east, because you you see a lot more kelps, you see a lot more species of starfish when they're not all dying from wasting disease. Turning over rocks, you can find all kinds of weird things under there, little sea urchins and stuff. So we'll hopefully be able to see a lot of that tomorrow. And a few of those things you can find on the other end, like the English Bay side, but not as much. The other place that I also like, and again, because it's pretty salty, it's a little bit further, is down around White Rock at Christopherson Steps or 1001 Steps. Those areas, like the Stanley Parks, the girl in a wetsuit site does have low intertidal kelps and other things, and you don't find that down in the White Rock area. But there's big boulders where, there's all kinds of stuff growing on those. And especially at a good low tide, if you roll some of those rocks over, there are neat fish that live underneath the rocks at low tide. So that's another good place that students can have a lot of fun. But yeah, if you can get them all the way up to the island, amazing things to see there. And apps. I haven't tried Seek in the intertidal. Maybe we should try that tomorrow, see how well that works. iNaturalist is a really good thing to use. So if you're making observations, you can get suggestions. Oh, what was this purple worm I saw? And post it, and people will, give you their opinions on what they think that is. Yeah.
I live in the North Shore, so when do you start to see sort of those effects as you get closer to the arc? So like everything, if you continue to move east, you progress east, when do you start to see a reduction then because of this varying spring levels and the effect function?
Yeah. I've drawn this in a way that I can't add the rest of the map because of where the screen is. But it's so industrial in the center, section of Berardin that there's not a lot of opportunities to check. Yeah, and so places like Kate's Park, I was in Belcarra Regional Park on Monday. They don't seem as diverse to me as the Stanley Park site. And I think that may be that actually squeezing through the narrows here creates so much mixing that you're actually bringing up some of that saltier and probably nutrient-rich water, nutrient-rich partly because there's this big sewage outfall over here. But yeah, so yeah, hey, finally. So it really does look different by the time you're in like Deep Cove, base of Indian Arm. But I would say it's still a little bit more diverse there than like right off the campus. But the other change is it's actually several degrees hotter in Deep Cove, just in terms of like afternoon air temperature, than it is if you went down to Wreck Beach. And that's a little bit unfavorable to diversity on that side. So there's multiple things changing, and then who knows what strange things are leaching off all the ship hulls from Reed Point Marina and everything else.
One question. It's kind of funny because I'm Japanese heritage, not Japanese, and I was like lady's home for dinner, and her husband, and then she had these appetizers made out of seaweed and kelp. And where did you get? She said, "Oh, I got the kelp and seaweed from Jericho Beach." And I was like, "Oh," but I mean, without being rude, I live. What are the conditions like? I think it was like in the spring, so it was really raining. Or
so the biggest risk of eating things locally is the bioaccumulation of toxic, like harmful algal blooms, and seaweeds don't do that. So the other problem is E. coli. So as long as you rinse the seaweeds pretty well, yeah, then like I wouldn't be afraid for my life. I also wouldn't be rushing down to that particular shore to collect. But yeah, there's like clams and oysters, I definitely wouldn't eat from these areas. The shellfish is like all of that is closed by DFO, and for good reason, because people could get paralytic shellfish poisoning or other ailments which are considerably more serious.
Another question from Zoom around salinity and crabs.
So some years the molts on the shore are incredible. What might the effect be on crabs?
Ooh. Effects of salinity on crabs. I teach an experimental invertebrate biology course where we work with the shore crabs a lot because they're very fun and very easy to get. And there's definitely, if you get the water fresh enough, they're not super happy about it. But then there's interesting things you can try, like as you lower the salinity, eventually they're like, to heck with this, and they crawl out. But if you give them a little hiding place, they're willing to tough it out for longer because that's more important. They're like, oh, this sucks. I never want to leave my little home. Yeah, so it does matter. But in terms of, like I have not done big surveys on the beach to see how that population is changing and whether, like some years the Fraser goes up to 12,000 cubic meters a second, and other years it barely hits 6,000. So a big difference. And does that have an impact on the shore crabs? Almost certainly. What exactly that impact is, I'm not sure. Yeah, that's a good question.
And then it would make us also wonder about the juvenile Dungeness and red rock.
Right,
People tend
yes.
to care more about.
Yes.
Because they are harvestable.
Yeah, and in deeper water, so a lot of this salinity sits right at the surface, the top 5-ish meters. So populations of Dungeness that are deeper than that are fine. But a lot of the juvenile Dungeness do actually like to come right inshore, and a lot of the red rocks come into the intertidal and hide under a rock to molt. So one of that I told you I walked my dog down to that beach to get salinity samples. One of those was in the winter, and right at the water's edge, there were all these juvenile Dungeness crabs that were about this big, and my dog was beside herself. She's like trying to paw at them, but pinching. So some of those populations, especially the younger ones, maybe in surface waters in that way. But things that are happening in Burrard Inlet are not going to be the same things that are happening, at the up on Quadra Island or down, around Victoria. It's a really beautifully complex ecosystem and oceanographic context.
I'd like to ask a trivial question. I'm not trying to be a joker, but I really like lobster and I like shrimp. And then somebody told me that they're related to cockroaches. And I had a hard time eating.
They just want to work
Or-
themselves.
Yes, it's more for me. So they are cockroaches. They're such a no. They're all arthropods, so they are related at some level. But the insects and the decapods, which include lobsters and shrimp, those diverged so long ago. It's there's you're fine. Let's go. Yeah. Yeah, actually, just a quick side. So you know what else is related to shrimp and lobsters and is surprisingly delicious is barnacles. So yeah, delicacy in places like Portugal and Chile, the big gooseneck barnacles where you can get some actual meat out of the stock, and they taste wonderful in garlic and butter. Yeah. Well, fair enough. Yeah. So I would not be worried about the cockroach connection.
Question obviously from a vegetarian like myself, about protecting marine algae.
Mhm.
So thinking about the images you were sharing about the marine algae, it shelters the mussels and the importance of that species or algal.
Yeah. So those of you who were here while we were getting set up might have overheard that my computer crashed about 2 minutes before I was planning to walk over, and the slides that were killed in that process because they hadn't saved was a comparison of a shoreline over in Belcarra before and after the heat dome for Fucus is the name of the rock. And it was a really depressing wipeout of this. It just looked like a lush meadow in the beginning of June of that year. And then by the middle of July, it was mostly bare rock. And the reason I wanted to show you that and make you sad was that I could then show you the picture that I took on Monday where it's mostly recovered. So some things are pretty resilient and they bounce back, but not everything. So a lot of the kelps, their life cycles just don't facilitate this big, boom bust, come in droves, and then you don't see as many the next year. So we're really worried about bull kelp in this area. One of my colleagues is working on trying to find specific strains of bull kelp that can survive the temperatures and salinities that we're now seeing. You can see a few of them in Stanley Park. We'll see some tomorrow, no doubt, Lighthouse Park. But to get really good beds of those, you've got to get out to colder, saltier areas, straight up Juan de Fuca has got loads. People are thinking about that. There have been documented losses of kelps. My master's student has shown that the low intertidal kelp sea cabbage is it's being pushed down into the subtidal, where it mostly gets eaten by other stuff as it gets hotter. So kelps are changing a lot. And then in terms of there's lots of seaweeds that one can eat. So some that are farmed, like the nori that you wrap around sushi. I'm not sure, but in some cases, water that's a little bit warmer is not necessarily a terrible thing, like for oysters. But a lot of these seaweeds are cold water species, and so you wouldn't want to try to grow it in warm water because it just, gets all funky and messy. Any other questions from the assembled group or the unassembled group?
Well, I had lots of questions, but I've already asked them, but I am interested about that sunflower star and why it's now experiencing the wasting disease, because it's a deeper water species.
Yeah.
And it's a trouble, isn't it?
Yeah.
Yeah.
So for people who don't know the sunflower star, I'll tell the following story. When I was a graduate student, I did some work with third grade students where we would come to the classroom and talk about stuff. And then we would all go out on a boat, and me and my friend would scuba dive and collect some stuff and bring it up and make a look at this. And so as we were just about to jump into the water, I asked, are there any special requests for what we should bring up? And one kid was like, bring the biggest starfish you can find. Like, okay, and we go in and we have these mesh bags for things, but sunflower stars have like 24 arms, and they're like utility hole cover size. And so I scooped one of those up, and it doesn't fit in the bag, so I'm just like carrying it under my arm, and I stop paying attention, and it slowly wraps all the way around my body and like knits its arms together, pinning my gauges down, so I can't tell how much air I have left. And so we came back to the surface, and I like rolled over on my side, and the students were like, "What?" And they helped, pull it off. So these enormous, glorious animals, and they are the poster child for the wasting disease because they have been hit the hardest. Why have they been hit the hardest? Good question. They really do die at the drop of a hat when you really even get a whiff of this pathogen. And one of my former postdocs is studying that. They've got a special facility down in Washington. So we're really worried about those. Someone had alluded to the fact that there are a couple of fjords on the central coast where, for whatever reason, the sunflower star populations are okay, but that's really the exception because, I used to see those at low tide in Stanley Park, and that never happens now. And I used to see lots of biggish ones up on the central coast where I work, and now occasionally you find like small pancake-sized, maybe 1 year old. But they seem to, as they get older, it just, maybe it's because it takes them longer to mature. They don't have a rapid turnaround like some of the intertidal ones do. Yeah, but they also just seem really vulnerable to disease. I don't know what it is about them that makes them more vulnerable, but yeah, they're in trouble. They're in danger. Does anyone have a less depressing question to end on?
Green crab and how it's doing in the.
The invasive European green crab. I'm involved with a nonprofit society for monitoring and eradicating the green crab currently in Boundary Bay. So
Down in the Semiami, the Friends.
Yeah. So I'm just wondering if maybe there will be a negative impact of climate change on that particular species, or
They're originally from Europe and are doing very well in warm-ish waters in the Atlantic on the North American side where they've been introduced. I think, and they're fine in San Francisco Bay, which is a lot warmer. So I don't think the Strait of Georgia is going to get too hot, unfortunately. So we can add them to the list of introduced species, which are going to celebrate a little bit more climate change. And yeah, it's been interesting watching their spread because they marched up the coast from California relatively easily. And then they got to like Barkley Sound and they had a heck of a time turning the corner because that was working against the surface current. But then, according to this one study, there was a weird year where there's like a burp of water in the other direction and some larvae arrived and now they are in Boundary Bay and yeah. Yeah, so I have yet to see one on any of our local beaches, but it's only a matter of time. We should do one of the, how they have those games, like when will the car that they dragged out onto the ice in Alaska fall through and everybody picks a date and a time and you win the pool. We should start a betting pool on when we collect our first crab from Burrard Inlet. It won't be long. I bet it's within 5 years.